Okay, in this particular problem, this is chapter 3-4, we're going to evaluate piecewise functions. Now, all this means is that we have a function cut into pieces, or a graph cut into pieces. And if you notice, it's cut into two pieces with two restrictions of the domain. Now, your domain are your x values. Now, notice right here, this is nothing more than f of x. So what it's saying is, hey, whenever you have an x, you're going to plug in -3 for it. Or whenever you have an x, you're going to plug in a -0.2 for it. And so forth with 0 and the 2. So we're going to evaluate these with these particular functions to the right with the domains. Alright, so first of all, let's look at this one right here. We're going to evaluate f of x equals -x. So f of x equals -x. But we have to do it when x is less than 0. Well, the only two that are less than 0 are the -3 and the -0.2. And the only thing you do is plug them in for x. So let's do that. So f of -3 equals put in parentheses, -3. And what you end up getting is f of -3 equals, now -3 is actually a positive 3. And so what that leaves you with is when x is -3, y is going to be positive 3. And it kind of gives you a coordinate point. Now let's do the next one. Let's do f of -0.2. So we're going to plug that in to -x. So that's going to be -0.2. So what I end up getting is -0.2, f of -0.2 is equal to a positive 0.2 because a negative is a positive. So what I can say is when x is -0.2, y will be positive 0.2. And so that's just one example or two examples of how to evaluate. You just plug them into the corresponding functions. Now, let me move this out of the way. Let me minimize this just a little bit. Alright. Now what we're going to do is we're going to do this function. But notice it has the restriction of, we have f of x equals x plus 1. But it has a restriction that x must be greater than or equal to 0. And the only two that do that are these two. So let's go ahead and plug those in. Let me make this a little darker here. Alright, so I want to evaluate f of 0 equals, and what we're going to do is we're going to plug that 0 in for this x. So 0 plus 1. And what you end up getting is 0 plus 1 is 1. So when x is 0, y will be 1. And again, that's with the restriction of x must be greater than or equal to 0. Well, let's do it for f of 2. Alright, into x plus 1. We're going to plug that 2 in for x. And so f of 2 equals 2 plus 1. I didn't put a parentheses around it because there was nothing on the outside that was going to change it or anything. So f of 2 is equal to 3. All that means is when x is 2, y will be equal to 3. And notice it gives you a coordinate point afterwards. Now let's take another look at that same function but in a different format. Notice we have f of x equals -x and f of x equals x plus 1 with the same domain restrictions, okay? So what we're going to do is now we're going to, instead of evaluating them just one at a time, we're going to look at them in a table. So for instance, if we look at this one, I want to find out the f of x when x is -1. Well, -1 is less than 0, so I'm going to plug that into here. So if I have -1, that becomes +1. And so that's what goes in that box right there. Alright, let's try -0.1. So again, since it is less than 0, I'm going to use this top one. So -0.1, and that becomes +0.1. Okay? Now, let's take a look at this bottom graph, this one down here. In this particular one, notice we have 0, 0.1, 0.9, 1, and 2. Well, those numbers are actually these. They start with 0 and they get bigger. So anything that's equal to 0 or larger than 0. And so now for this bottom section, we're going to use this one. So notice we want to find 0.9 and 1. So let's go ahead and plug those in. So if I have f of 0.9 equals 0.9 plus 1, notice I substituted x in for 0.9, or 0.9 in for x. 0.9 plus 1 is equal to 1.9, and that's what I put right there, 1.9. Alright? Let's plug in 1. So f of 1 equals, and now remember it's x plus 1, so I'm going to plug that 1 in for x, just to remind you. So 1 plus 1 is equal to 2. So f of 1, when x is 1, y will be equal to 2. Now, what we're going to do with this is now we're going to take those numbers and we're going to look at a graph. Okay? Now notice what it says here. It says the transition from one rule, which was negative x, that's this top one, to the other rule of x plus 1, that's this one, occurs at 0. Well, what do they mean by that? Well, if you look here, this one says, hey, everything applies as long as the x's are less than 0. And then this one says, hey, everything applies as long as x is equal to 0 or greater. Well, let's look at what that means on a graph. It says, show an open dot at 0, 0. And notice that's what they did right there. They put an open dot. That's where the transition is. Because the point is not part of the graph. Now, this left part was the negative x. Alright, that's this graph right here. So that's just like saying y is equal to negative x, or in this case, since we're talking about a function, it would be f of x is equal to negative x. That describes this line right here. Now, what we're going to do, according to these instructions, is show a closed dot at 0, 1 because the point is part of the graph. Now, what we're going to do is we're going to plot all these points. So if you notice, negative 3, 3 is right there. Negative 2, 2 is right there. Negative 1, 1 is right there. And of course, it keeps getting smaller and smaller and smaller. But we do know that x must be less than 0. So that is why they put an open circle in there, because x has to be less than 0. Now, let's take a look at this next one. I'm going to plot this point 0, 1. So that's a point right there. It's part of this second part. And then, I don't know where these are, but I'm going to go ahead and plot these. These are easy. So 1, 2, and 2, 3. And then I'm just going to connect those with a line and go this way. Now notice, this is open circle, this is closed. And notice you have two parts. This is what you call the piecewise function. Okay, now we're going to take a different look at it. I'm providing you with the graph. So what we're going to do is we're going to take this graph and we're going to fill in this table. And then from this table, we're going to come up with the functions. So we're going to kind of work backwards here. Alright, so let's go ahead and take a look. Let me minimize this just a little bit. And let's fill in this table here. Alright. Now, it says when x is negative 1. Well, when x is negative 1, that's this line right here. Notice it's included here, but not here, because that's an open circle. So let me go ahead and erase this. So when x is negative 1, y will be positive 1 because of that point right there. When x is negative 2, y will be 0. When x is negative 3, y is negative 1. When x is negative 4, y will be negative 2. And I bet you this one will be negative 3. Alright, and so those are the table values of the ray. Now, let's take a look at this. Let's take a look at this statement here. The value of y is blank more than the value of x. Well, if you take a look at this, the value of y is actually 2 more than the value of x. So if you look at a number line, 0, 1, -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. Well, here's -5, -3. Well, if you notice, this is when there's 2 more. So this is 2 more. And if you look at -4, which is right here, and -2, again, 2 more. So all of these happen to be 2 more than the value of y. Okay, and since it's 2 more than the value of y, now we can create an equation for this. And that equation would be y is equal to x plus 2. Because for every x, we're going to add 2 to it to get the next y. Now, the equation of the line that contains the horizontal ray is y equals blank. Well, let's take a look at the graph again. Now, if you take a look at this graph, notice, if you remember my story, okay, plus, negative, 0 slope, and undefined. Well, in this case, this is a y equals. If you have a vertical line, it's an x equals. So right now, we're dealing with a y equals function or equation. So let me get rid of this. And in this case, this y equals, notice it's y is equal to 3. And that's what we're going to put down below. So let's go down here, and it says the equation of the line that contains a horizontal ray is y is equal to 3. And we're going to put both of these right here. So if you notice, look at the restrictions. X is less than or equal to -1, and then x is greater than -1. Well, let's take a look at this. This right here is where the x's are less than or equal to 1 because they're all this way. And then, oops, sorry about that. And then this particular one is x is to be greater than 1. It cannot be equal to 1 because that's an open circle. So now we're going to apply those to the appropriate function. So we're going to put x plus 2 here, and then this one is 3. So what you end up having is f of x is equal to x plus 2 as long as x is less than or equal to -1. And then you're going to have f of x is equal to 3 as long as x is greater than -1. This is approximately a 10-minute video, and I apologize for the length of it, but we will practice more of this in class tomorrow.